All right, in this video, we're going to be talking about normal distributions again, and I'll refresh your memory. Last time we talked about kind of where the normal distribution comes from. We looked at a few examples, and this video is going to be talking about some calculations we can make within our normal distributions. And so I'll just remind you of an example too. We can go back to our Plinko example, and this is dropping balls down these little Plinko spots, kind of like the Price is Right show. And it's dropping a bunch of them all at the same time, and it fills these counters. So I've been running this for a while, and you can see how it's giving us the shape. I have the ideal clicked here. It's giving us the near ideal normal distribution curve. And you can see how the average or the mode or the median is right down the middle here in bin 6. And it's really hard to get to the ends because you need a half chance to fall to the one side all the way down. And most of those balls are falling right there in the middle. So it's a good example of where the normal distribution curve shows up in the real world. So we'll go back to our graphs here. So once again, normal distribution curve, we have the mean, otherwise known as mu, right down the middle. And remember the area under the curve. This is a probability distribution, so the area under the curve must equal 1. And the standard deviation tells us how spread apart the data is. So the larger the standard deviation is, the wider this graph is going to be, and the smaller the standard deviation is, the skinnier and taller it would be. And here's our IQ example. Refresh your memory again. IQ scores of 100 are right down the middle. And then this has a standard deviation of 15. So we can see that 68% of all humans have an IQ between 85 and 115. So what we're going to be doing is calculating something called a z-score. This is really important. It's going to show up in our next few chapters. So a z-score is only going to work for a normal distribution. So whenever you see a normal distribution, this capital N or this shape, you should think a z-score will probably be involved. So this is x is normally distributed with a mean and a standard deviation. Then to find the z-score, what we do is we calculate the distance from the mean and we divide by the standard deviations. So we'll do an example and this will make more sense, but the z-score tells us how many standard deviations the value of x is to the right or to the left of the mean. Values of the x that are larger than the mean have positive z-scores, and values that have x that are smaller than of the mean have negative z-scores. And if x equals the mean, then the z-score is 0. And let's look at an example here. So, for example, if the mean of a normal distribution is 100, so I'm thinking of our IQ example again, the mean is 100 and the standard deviation is 15. We want to find the value of 145. And the value of 145, I'll just tell us, is 3 standard deviations above or to the right of the mean. And we can see that here. The mean is right down the center. Here's 1 standard deviation, 2 standard deviations, and 3 standard deviations. So an IQ of 145 says you have a higher IQ than 99.9% of all humans. And to calculate the z-score, using our formula, it looks like this. So x is our value of our person. And so x is 145. That's our data piece. Mu is the average or the mean. So that's 100 in this problem. And then this sigma, lowercase sigma, stands for standard deviation. So I plug 15 in for the standard deviation because they tell us here standard deviation is 15. So I get 45 divided by 15, so 3. So this is a z-score of 3. And if I go back and look at this graph, so using z-scores, this would be a z-score of 3 because it's 3 standard deviations above the mean. This would be a z-score of, what do you think? 2, because it's 2 standard deviations above the mean. This would be a z-score of 1, z-score of 0, -1, -2, -3. And I can show that on this graph. You can see the z-score of 0 right down the middle. Here's the z-score of 1, 2, 3, and then negatives on this side. Okay, so there's our formula for z-scores. Here's our graph showing z-scores. Let's try another example. Suppose x is remember, capital N means normal distribution. Capital U means uniform distribution, the rectangle one. Suppose x is normally distributed. Remember, they always tell us the mean first and then the standard deviation. A mean of 5, standard deviation of 6. So this says x is normally distributed with a mean of 5 and standard deviation of 6. Suppose x equals 17. Then we want to find the z-score. So we use our formula, where x is our input. That's our data piece, 17. Mu is our average, 5. And sigma is our standard deviation. So we take 17 minus 5, 12, divided by 6, 2. So this score of 17 is 2 standard deviations above the average. So 2 standard deviations above or to the right of the mean. Standard deviation is 6. So here we can also show that 5 plus 2 of those standard deviations, that takes us to 17. You don't really need to go through and check your work like that. Let's try another one. How about x equals 1? Well, I think I have a picture of this. Yeah, here's 17. So here's 5 right down the middle, standard deviation of 6, and then here's 17. The next one's going to ask us about 1. We're going to find the z-score of where 1 would be. So take note, 1 is less than the average of 5. So this should be a negative z-score. So we use our formula. We plug in 1 for x. The average or mean is still 5, and the standard deviation is still 6. So 1 minus 5, -4 divided by 6, -0.6666 repeating. So -2/3. Or they rounded it, -0.67. So that means an x value of 1 for this problem is 0.67 standard deviations below or to the left of the mean. So to summarize, when the z-score is positive, that means we're to the right of the mean. When the z-score is negative, that means we're going to go to the left of the mean. And next time we're going to talk about this rule. So a little preview here. And this rule is going to show us the percentages involving our standard deviations. So 68% of the data is between left of 1 standard deviation and right to 1. So let me show that here. So here's the average. So 1 standard deviation to the left, 1 standard deviation to the right, we get 68% of our data. So if we think back to that IQ example, between 85 and 115, 68% of all humans are. Next is 95% are within 2 standard deviations of the mean. So within 2 standard deviations of the mean, 95% of our data. Then within 3 standard deviations of our mean, we get almost everybody, 99.7%. Okay, that's this called the empirical rule, the 68, 95, 99.7 rule. Okay. Next time we'll do some more calculations with that.